Hello and welcome to this second episode on the domestic uses of electricity in homes. Now again, the first episode didn't sound like it was going to be fun, but it was. And domestic use of electricity is a very exciting topic, I think we'll all agree. And it's something you need to know for your GCSE Physics. So let's get straight in and look at what you need to know. If you haven't listened to that first episode on domestic use of electricity in homes, then I recommend you do that before you listen to this episode. So appliances in the EU have a label or panel that tell you what the power rating of an appliance is. And the power label can be used to calculate the current required by the appliance using the following equation. It's power equals potential difference times current. Or we can say power equals the current squared times by the resistance. And 230 volts is the potential difference across the mains power supply in the UK. And we can work out how much energy an appliance transfers using the power rating and the equation. So the energy transferred equals power times time, and then the energy transferred also equals charge times potential difference. So for example, a 100 watt lamp will use 100 joules of energy each second. So let's look at that in an example. So what is the current required by an appliance of power 460 watts if it is plugged into a mains? Well, remember, power equals potential difference times by the current, and we can rearrange that to say the current equals the power divided by the potential difference. And remember that 230 volts is the potential difference of the current of what comes out of our plug sockets in the UK. So we can say that the current is equal to the power, 460, divided by number of volts, 230, which gives us 2 amps in total. And if we've got a 50 watt bulb, per second, it uses 50 joules. That's the conversion between watts and joules. So the national grid is also something you need to know about, and that's just a network of cables and transformers that connect power stations with houses and shops and businesses across the UK. And power stations create electrical current, which is an energy carrier, and then large power stations are more efficient than smaller ones, because they can burn lots of fuel at very high temperatures, and this creates hot steam which then turns turbines. And steam turbines are more efficient at higher temperatures. Now, power stations produce electricity at a voltage of 25,000 volts, which obviously isn't that useful for your everyday appliances. So step-up transformers then increase that potential difference to 400,000 volts. That basically reduces the current, and this reduces how much heat is lost when it's being transported across the country. And then this also increases the efficiency of the national grid system. And then you get something called a step-down transformer that makes electricity come into our homes. So to get electricity to a safer voltage of about 230 volts in our homes, step-down transformers reduce the voltage to a lower value. So to recap some of those parts of the national grid again, we've got, first of all, the power stations, then we've got step-up transformers, which increase the voltage and reduce the current, and then we have step-down transformers that put it down to 230 volts, and that then goes into homes and businesses. And remember, it's 230 volts is the potential difference of the main power supply in the UK. So let's have another look at an example. So say this time we have 690 watts of an appliance that has a power of 690 watts, and it's plugged into the mains. What is the current required by the appliance? Remember, power equals voltage times current. So current equals power divided by voltage. And voltage is 230 because it's plugged into the mains in the UK. So we can substitute in the values we want. We've got 690 divided by 230, which will give us a current of 3 amps. Now, a quick question for you. Can you remember what the national grid is? Well, if you weren't sure, the definition of the national grid is a network of cables and transformers that connect power stations with houses and shops in the UK. And remember, some parts of the national grid are, first of all, the power stations, then step-up transformers, then step-down transformers, and homes and businesses. Now, how much energy is used by an appliance with a power rating of 10 watts connected to the mains for 5 seconds? Well, there's some equation you need to know, which is energy equals power times time. And substitute in the values you know, energy equals power 10 watts times time 5 seconds. So that will tell you that the energy is 50 joules. And that is all we're going to look at for domestic usage of electricity in homes. I told you it wasn't going to be that exciting. I hope I proved you. I told you it wasn't be that boring. I hope I proved you right in that. But if not, then this is something you need to know. It's really important for your exams. Join us again next time. We're going to look at electrical safety in homes. Again, I promise you it's going to be riveting. Join us again soon.